This lesson is 5.4, adding and subtracting rational expressions. A lot of what we are going to be doing with adding and subtracting is what we did in 5.3 with simplifying rationals. So let's go ahead and take a look at what we're going to be doing in this lesson. Our goal is to be able to add and subtract rational expressions. So we are going to look at basic fractions because our basic fractions lead into how we're going to be doing this with rational expressions, with polynomials in the numerator and the denominator. So our rules for adding and subtracting rationals come from our rules of adding and subtracting basic fractions. So if I want to add or subtract a fraction, they have to have common denominators. So if I'm going to add or subtract rationals, which is polynomials as a fraction, they have to have common denominators. So for A, we have 1/6 minus 5/6. We have a common denominator. There's 6 in the bottom of both fractions. When I have a common denominator, all I do is I do the operation on the top. So in this case, it's subtraction. 1 minus 5 is going to give me 4, negative 4. And then the denominator stays the same, stays your common term, 6. Now, once I subtract, I always need to make sure it's simplified. And in this case, it's not simplified because 4 and 6 have a common term of 2. So I can divide out a 2 to get a simplified fraction of negative 2/3. So this subtracted would result in the answer of negative 2/3. So we're going to look at adding and subtracting rationals with like denominators. We also are going to look at adding or subtracting with unlike denominators. So in B, 10 and 5 are not the same. So my goal is to get a common denominator, a denominator that is the same. So I always want to see, can I make one of the terms turn into the other by multiplying? If I can, I only have to multiply one of the fractions. If I can't, then I have to multiply both. In this case, 5 can become 10 by multiplying by 2. So if I take 5 times 2, I get 10 in the denominator. So I would have 3 over 10 minus, and I would have 10 in the denominator. But if I multiply the denominator by 2, I change the fraction. I want to keep it the same, I just want it to have a common denominator. So in order to keep it the same, I have to do the same to the top. So I have to multiply the top by 2 as well. So then I would have 2 times 2 gives us 4. Now that I have common denominators, I can just subtract these two fractions, and I would have the numerator 3 minus 4 would give me negative 1, and then on the bottom I keep my denominator of 10. 1 and 10 can't be simplified, so that would be my answer to subtracting 3/10 minus 2/5. So now we're going to look at doing this, but with rationals, with x terms. We're going to start with a couple examples of like denominators before we get into unlike denominators. So if we look here, we have a fraction subtracting a fraction. So we are subtracting here, we're subtracting two rationals, but they have a common denominator. So x minus 5 is the denominator of both fractions. So this is the same thing as what we just did previously, where we just had 6 in the denominator. So here, if I'm going to subtract these, I'm going to subtract the numerator. So 2x minus 10. 2x and 10 are not like terms, so they just stay separate. So I have 2x minus 10. And then in the denominator, I have x minus 5. It's my common denominator, so I keep it the same. Now, just like I simplified my fraction, I want to simplify my fraction. And this leads into what we did in 5.3, where we had to factor to then go ahead and simplify. So here, I can factor out a GCF on the top in the numerator. I can take out a 2. And when I take out a 2, I'm left with x minus 5. And in the denominator, I have x minus 5. So remember, if I have two factors that are the same, they cancel. So my resulting answer is just 2. That would be my simplified result, 2. Let's look at one more example with a common denominator. So we want to add or subtract here. Our denominator is x squared minus 5x minus 14 in both fractions. So I can just go ahead and add the numerator, keep the denominator. So if I add my numerator, I'm left with x squared plus 2x. X squared, x are not like terms, so I don't combine them, I just leave them separate. And then my denominator is x squared minus 5x minus 14. All right, so now that I've added them, I want to simplify my result. So I'm going to factor the top. 2 terms, not a difference of 2 squares, so I just take out a GCF, which is just x. And I'm left with x plus 2. And then in the denominator, I have 3 terms with a lead coefficient of 1. So I'm thinking, okay, what adds to negative 5 and multiplies to negative 14? Well, it's going to be 7 and 2. And since I'm adding to a negative, my larger number has to be negative. So I've factored the top and bottom, so now I need to see if anything cancels. And I have an x plus 2 on the top and bottom. So my simplified result of adding these two rationals would be x over x minus 7. And don't forget, if we were looking at domain restrictions like we did in 5.3, we would look back at this piece here to get our domain restrictions of x can't be 7, x can't be negative 2. But right now we're just looking for our simplified result. So adding or subtracting with like denominators isn't so bad. You just add up the numerator, keep the denominator, and then simplify the result as we did in 5.3. Now we're going to look at, well, we have an additional step if we have unlike denominators. So our first example with unlike denominators would be add or subtract and then simplify this result. So we have 5 over x minus 7 over 3x. So in our denominator, it's not the same. I have x and I have 3x. So what I always want to look to do, like I did when we were just doing basic fractions, was can I just multiply one of the fractions in order to get it to be the same as the other? So I can take x and multiply it by 3 and turn it into 3x. That way both fractions would have 3x in the denominator. So here, if I multiply this first fraction by 3, I have 3x in the denominator, just like the fraction on the right. If I multiply the denominator, I also have to multiply the numerator, so I keep things the same. And when I do that, I get 15 over 3x minus 7 over 3x. Now that I have like denominators, it's just what I was doing before. So I have 15 minus 7 is going to give me 8. And then 3x in the denominator. 8 and 3, nothing cancels, so this would be my simplified result. 8 over 3x. With example number 2, things start to get a little trickier. So I have m over m minus 2 minus 8 over m squared minus 4. Now, m minus 2 and m squared minus 4 are clearly not the same. So we have to create like denominators. Now, if we have something in the denominator that can factor, we want to factor it first because that's going to see, do they have anything in common? And what do I have to multiply by in order to get them to be the same? So If something in factor like m squared minus 4, a difference of two squares, I want to go ahead and factor first. So this becomes m minus 2 times m plus 2 when I factor. What I notice is both fractions have m minus 2 in the denominator. They have that in common. So in order to get a common denominator, all I have to do is multiply the left fraction by what it's missing, what it doesn't have in common, which is m plus 2. Because now fraction 1 has a denominator of m plus 2, m minus 2, and fraction number 2 has a denominator of m minus 2, m plus 2. But if I multiply the denominator, I always have to multiply the numerator. So I'm going to have to multiply that out. So when I go ahead and multiply, I have m times m and 2 times m. So this is going to result in m squared plus 2m over m plus 2, m minus 2. And then I'm going to subtract that by 8 over m minus 2, m plus 2. Because I don't have to multiply the second fraction because all I did was factor. That is what my denominator is. I didn't multiply by anything. So it just stays the same. But now I can see my denominators are the same. They both have an m minus 2. They both have an m plus 2. So I can go ahead and subtract the top, keep the bottom. So that's going to leave me with m squared plus 2m minus 8. M squared, m, and 8 are all unlike terms. So they just all stay separate. And then my denominator stays the same. It doesn't matter what order you have them written in. So, like I said, this one starts to amp it up a little bit. So, got a couple more steps here. Now that I created like denominators and I subtracted, now I have to simplify. And in order to simplify, I have to factor the numerator now. So if I factor the numerator, I'm looking for what adds to 2 but multiplies to negative 8. So that's going to result in m and 4 and m and 2. And since the 2 is positive, the 4 has to be positive because we want our bigger number to be positive here. So 4 and negative 2 multiply to negative 8, but they add to positive 2. And then our denominator was already factored for us. So now that it's factored, do I have anything that cancels? I do. So my simplified result of this original problem is going to be m plus 4 over m plus 2. I subtracted and I simplified to get my final answer. All right, so another case that we can see with unlike denominators, because clearly 3x minus 1 and 2x plus 5 are not the same, is I can't make 3x minus 1 become 2x plus 3. They don't factor. There's nothing in common. So in order to create a common denominator, I have to multiply the first one by the denominator of the second, and the second one by the denominator of the first. So when they have nothing in common, you essentially just have to make them one and the same. So this first one, I have 3x minus 1. Well, I got to multiply by 2x plus 5. If I multiply the denominator, I also have to multiply the numerator. So this one gives me a denominator of 2x plus 5, 3x minus 1. So this one also has to be 2x plus 5, 3x minus 1. So I have to multiply by 3x minus 1. So now if I go ahead and multiply these together, this one I have to distribute on the top, there. So 2x times 6x is going to give me 12x squared. 5x plus 6x is going to give me 30x. And then my denominator, I'm going to end up having to factor anyways, so just leave them as factors. So the denominator can leave as factors. The numerator I want to multiply together so that I can go ahead and subtract my numerators. And then I'm going to subtract the numerator here, which is going to be 4x times 3x is going to be 12x squared. 4x times negative 1 is going to be negative 4x. And then I have my denominator. All right, so now that I multiplied, I want to actually go ahead and subtract now. So I have 12x squared minus 12x squared. So this is kind of like what we did with our imaginary numbers when we did subtraction. I can change this and distribute this negative in. So if I distribute a negative and distribute a negative, I'm changing the sign of everything behind it. So 12x squared plus negative 12x squared is no x squareds. And then 30x plus 4x is going to give me 34 x's in the top. And then in the bottom, I have 2x plus 5 times 3x minus 1. 34x, 2x plus 5, 3x minus 1. Nothing cancels here, so this would be my final result. There's nothing that I can simplify. That would be my result of subtracting these two rational expressions. And we have come to our last example. You can see that we have unlike denominators again. I'd like you to try this one on your own. So go ahead and pause the video, write down the problem, give it a try, and then hit play to check your answer. All right, so looking at this problem, we have x squared minus 25, and then we have x plus 5. Not like denominators, but remember, if I can factor, I want to factor to see if they have anything in common. So when I factor this, I'm left with, it's a difference of two squares, so x plus 5, x minus 5. So I can see that they have an x plus 5 in common. Well, they also need to have an x minus 5 in common, so I need to multiply this first one by x minus 5 so that they have the same denominator. So then I'm going to end up having to distribute on top. And when I do that, I'm left with x squared minus 5x over x minus 5, x plus 5. And then I'm going to subtract that with 50 over x plus 5, x minus 5. So I didn't multiply that one by anything, so I just leave it as it is. From here, I want to subtract. So when I subtract these two, I'm left with x squared minus 5x minus 50, because none of them are like terms, so I can't combine them. And then my denominator is the same, which is x plus 5, x minus 5. So now that I've got like denominators, I subtracted, I have to simplify. In order to simplify, I have to factor my numerator because my denominator is already factored for me. So 3 terms, lead coefficient, add to negative 5, multiply to negative 50. So I have options of 1 and 50, 2 and 25, 5 and 10. So 5 and 10 is what I'm going to have to use here. Since the 5 is negative, I have more negatives, so my 10 should be negative. So negative 10, positive 5. So then keep my denominator because it was already factored. So like denominators, subtract, factor, anything cancel. Well, my x plus 5s cancel. So my simplified result is x minus 10 over x minus 5. And hopefully that is what you got as well. So now to get even more practice with this, to make sure that we are proficient when we come into class, please go through and do the 5.4 worksheet where you have examples of like and unlike denominators that we're adding and subtracting together. If you have any questions, please come stop in to see me before class time tomorrow.